Well, thank you for that introduction, Mike. Today we are here to present a GIS solution to an important issue associated with the development of shale gas. I know the title of our presentation is a mouthful, but if you stick with us today, you'll see that the application blends many technologies into a comprehensive project solution. In the presentation today, we'll be providing you some background information on the problem we're trying to address with this application and the solution that was developed. We'll provide an overview of its functionality. Then Matt Smith from Development Faction will present the technology used in the application. Development Faction created this custom application, meeting the needs of our roadway managers and engineers. And then lastly, we'll discuss some potential future uses of the application beyond roadway and pavement defects. The issue we're trying to address with this application has been created by the road use regulations in Pennsylvania, Ohio, and West Virginia. Shale gas operators are required to bond roadways to use overweight truck traffic for their development activities. The operators are required to maintain those roads in a safe and passable condition. And they're required to restore roadways to a condition equal to or better than the condition before they use them. The significance of these regulations are that permits to haul on these roadways can be suspended by the regulatory agencies if the oil and gas operators do not maintain the roadways. And another significant impact of these regulations are that the costs to repair roadways are significant. The overweight truck traffic associated with shale gas development can be significant, with 2,000 to 3,000 loadings on average for each well, and that truck traffic varies by the different stages of well development. There's a different mix of heavy truck traffic for the site construction phase, for the drill rig mobilization phase, for hydraulic fracturing, and then the midstream and production phases. To demonstrate the magnitude of the truck traffic, I brought a short video clip from a typical site construction mobilization. The video is 2 minutes long, but I'll play it back at 2 times speed. The traffic represented in this video is only about 5% of the total amount of heavy truck traffic that's needed during the site construction phase. But this gives you some indication of the intensity of heavy truck traffic that happens during the drilling and development process. As you might understand, the vast majority of roadways impacted by this type of truck traffic were not designed to handle the loadings and intensity of the traffic. The consequence of this is that we see accelerated roadway deterioration and excessive roadway damage. Our solution to these challenges has been the development of a comprehensive roadway management strategy which uses various tools to keep oil and gas companies in compliance with the regulations and also to help reduce roadway maintenance costs. Some of these tools include performing pre-bond roadway field evaluations, performing engineering analysis of the existing roadways that are being utilized, predicting how roadways will perform under these anticipated shale gas traffic volumes, engineering our design of optimal roadway maintenance strategies, performing roadway condition monitoring, performing post-haul roadway field inspections, and performing construction management and inspection of roadway repairs. GIS technology has been integral in the development of our roadway management program. In addition, for several functions of this roadway management program, including pre-bond field evaluations, roadway condition monitoring, and post-haul roadway field inspections, video documentation is critical. The solution that was developed involved high-definition GPS-enabled video playback with web-enabled GIS. During all of our field inspections and roadway condition surveys, high-definition video is recorded with geotagging. The high-definition video specification is important for the work that we're doing in roadway management because often we're trying to determine if things such as roadway cracking has increased from the pre-haul to the post-haul condition. I brought with us today some video playback of the actual application, and I'm going to pull that up for you here. Okay. This view shows the basic layout of the web-based application. The video playback is shown on the left-hand side of the screen, and a web-based GIS map is displayed on the right side of the screen. The GIS map can be populated with various data sets related to transportation, and I'll describe some of those in a future slide. Currently, in the map view, the vehicle location icon is displayed along the roadway being traveled. As the geotagged video location advances, the vehicle position is updated. We also have the opportunity to display various base map options. Here we're displaying aerial imagery, and notice we're nearing some farm buildings. And in this video we had some friends that wanted to come and check out our video inspection. But you can see as we're advancing along our video inspection route, you can see that we're approaching some roadway damage that was identified by a previous inspection. This is an area of high severity edge cracking. It's approximately 108 square yards in area, and it was previously identified on the August 20th inspection on Susquehanna County State Route 3017. We also display the segment and offset location in PennDOT's linear reference system. And here you can see as we continue along the inspection, we see where the vehicle location and playback location are synced. In this next example, use of the application, this involves viewing only important sections of the video. Often our video logs are quite lengthy, but we're only interested in specific areas of the video to view and look at other pertinent GIS data. A common scenario is viewing roadway damage that occurs at an oil and gas driveway entrance. With the video player application, we can advance the playback to a specific section along the roadway to only view that section. By selecting a roadway point, the video player advances to this location, and we are able to view both the video and other pertinent GIS data, such as the access point location, which is shown as the orange cross on the GIS map. That access point location gives us GIS data such as the driveway permit and other important information. In addition to advancing the video player graphically on the map view, the video player slider can be adjusted and the vehicle location is updated on the map. In this example, we have moved the playback so we can review the roadway conditions at a second driveway to an impoundment. Another very important feature of this application is the ability to view all the roadway management overlay data from our web-based roadway management GIS application. In this demonstration, I'll describe some of the GIS data that we utilize during the roadway management process. The base map information provides official state and local road designations and numbers. This posted and bonded roads, there we go. The posted and bonded roads layer displays roadways with 10-ton weight restrictions or bridges with weight restrictions. We also display bonded users, which includes roads and names of companies hauling overweight on these roadways. Next, in this client roadways group, That allows us to track roadways that we're managing for oil and gas operators. Some other information such as the access points layer allows us to track driveway locations and their attributes. Next on this road inspection group, this displays information from PennDOT's weekly road condition surveys or data from more detailed roadway surveys that we conduct for individual clients. Height restrictions can also be displayed within this group by turning on the different layers of information. We have SRBC's web server data linked into our roadway management GIS. And lastly, the gas industry data allows us to display permitted wells, pipelines, active rig locations, and support industry facilities such as quarry locations and asphalt plant locations. Really anything that would be needed to manage transportation or roadway conditions for oil and gas activity. My last demonstration video here shows how the application allows us to easily sort and select among various videos that are typically collected along a roadway. Because road conditions must be monitored throughout various well development stages, we often take periodic videos to document the condition of the roadway and assess whether repairs need to be initiated along the roadway. In this video, we can see in the Inspections tab there on the screen a listing of all available videos for this roadway by date and description. This enables our staff of engineers and roadway managers the ability to easily find and view videos from various time periods. In summary, before I turn it over to Matt Smith from Development Faction to describe some of the technologies that his team has integrated to make this solution happen, I'd like to hit some of the key points of this application from my perspective. Number one, it's a web-based application, so it provides for ease of use between our engineering staff and shale gas operators, even though we're often located in different offices geographically. It allows us to see that video playback location on the map, and that video playback location can be changed by selecting any point along the route on the map. The integration of this video player with our GIS database allows us to see all available data in one view, and it enables the user to easily review multiple videos along the roadway to determine if the roadway condition has changed over time. Now I'll turn it over to Matt, who will talk a little bit about the technology involved.
Okay, thank you, Aaron. Hope you all enjoyed the video of that. It's a really cool application live, but it's web-based, so we didn't want to mess with that today. Video we thought would be sufficient. I'm just going to touch a little bit on some of the technologies that we used. As Aaron mentioned, 1080p HD video cameras mounted in the inspection vehicles, dashboard mount. They geotag the video, so GPS coordinates are recorded the entire time the video is being taken. So that's basically how we derive the locations to sync the application between the web app and the video. Just a little background. We did build an enterprise GIS system backend for Stahl and Sheaffer Engineering. It sets on Esri Arc Server 10.0, SQL Server 2008 R2 database. Microsoft Silverlight API is the basis of the web application. And then the video player itself is actually is YouTube. So they're you guys kind of uploaded right to the web, right? Mm-hmm. Yeah, they haven't even caught on to that yet. So they don't charge you for that, right?
No, it's free.
And they have tons of videos on there.
Thousands and thousands of videos uploaded to YouTube. The only issue that we have is if somebody's playing music in their car and it picks up on a copyrighted song, then it shuts off the audio or flags a warning. So we have to tell our inspectors to keep their music low.
So that's the general concept. A little bit more into some of the actual technologies. As I mentioned, the core technologies that we used are Microsoft technologies, .NET technologies, except for the YouTube video player itself, which is Flash. Flash and Microsoft, they're not really meant to talk together, to work out too well together. So we had to do quite a bit of legwork to make that work on our end. So the YouTube video is Flash. We built some custom video codecs for compressing the videos, and some algorithms for managing them, storing them, archiving, things like that. The web application itself, like I said, it sits on ArcGIS server, Silverlight API. Some of the programming we used for that, Microsoft C#.NET. Some of the other languages that we used for the web application, XAML, Extensible Application Markup Language, XML for config files, and of course WPF for some of the interfaces. That's the general gist of it. I'd be happy to talk a little bit more, answer some questions about the technology. Of course, I'm not going to tell you exactly how we did it because we put a lot of work into that. But I'd be happy to elaborate on it a little more. We'll go ahead and let Aaron take over and explain the rest of the application and how it's benefited the industry. And again, I'll be around for any tech questions you may have. Thank you.
Thanks, Matt. Okay, in summary, the benefits of this application include that it allows us to accurately document roadway conditions over time. From the engineering side, we use this to help develop optimal roadway maintenance strategies because we're able to monitor the rate of roadway deterioration. It allows us to initiate roadway repairs before they become a safety or regulatory issue for the oil and gas operators. And it also assists in negotiation of responsibility for roadway repairs when multiple oil and gas companies are using the same roadway. And here you can see in a couple snapshots of different videos how the conditions of the roadways do change over time, particularly with the different seasons and accelerated roadway deterioration that we see in the spring thaw period. Although this application was primarily developed for transportation and roadway usage, it would have wide use in the documentation, inspection, and management of any linear asset, including pipelines, electrical, telecommunication facilities, rail, or right-of-ways.